Good morning, students. Today we are going to learn about argan plane. Argan plane hai se kaino tamsi ko. Koina lower class ta Cartesian plane hai se khange ko. Cartesian plane hai di kaino real numbers mayam represent the river plane da. Cartesian plane ko we. In Cartesian plane there are two lines, horizontal line and the vertical lines. Horizontal lines is called x-axis and the vertical line is called y-axis, and any coordinates or other pairs 2, 3. Example na 2, 3 hairaseba. Say locate tawba ngameba. Kamaina locate tawba ngame by moving two divisions along x-axis. X-axis ta nang division ani chalaga, and moving 3 divisions along y-axis. 1, 2, 3. Sumaina locate tawba ngame ko. X ta na division se kya chali? Ani chali. Y damuk division se kya chali? Ahum chali ko. Sigi mawang da khoina order pair 2, 3 habise represent tawba ngami or locate tawba ngami hairani ko sa. Siga chapmana na khoina complex number sisu kaidawba yai represent tawba yai. Example loina complex number z1 1 plus I haraseba ko. 1 plus I say x plus I y ni. X means real part and y means imaginary part ni. Here x is equal to 1 and y is equal to 1, and so this complex number z1 can be represented in this plane whose coordinates are given by kaina pirani. X is equal to 1 and y is equal to 1. Real part china x ta doiba, imaginary part china kya ta doiba? Y ta doiba ko. Dena sida 1, 1. Si point B gumba harasi ko. Point B represents the complex number z1 1 plus I. Then similarly z2 can be represented in this plane. Here z2 complex number is equal to minus 2 plus 3i. Here real part is equal to minus 2 and imaginary part is equal to 3. Minus 2 si lere ko, and plus 3 division chalo 1, 2 and 3. See where is it ko? This point C, minus 2 and 3. Sigi coordinates se minus 2 and 3 neba. Sigi minus 2, 3 se kana represent away hai tardi complex number z2 se represent away. This point C is representing the complex number z2 minus 2 plus 3i, whose real part is minus 2 and imaginary part is 3 niko. Dune any complex number se koina kai oina represent away hai heba, point oina represent away hai ba. Any complex number can be represented as a point in a plane, and that plane is called argan plane. Since all the real parts are represented along x-axis, so in argan plane this x-axis is called real axis. Koina argan plane the real axis hairani, x-axis hairaroibuko, and imaginary parts are represented along y-axis, so this y-axis is called imaginary axis. Dudi koina argan plane haise kaino haise hairani ko. Argan plane means the plane in which all the complex numbers are represented as points is called the complex plane or the argan plane. Complex plane hairagasu yai, kai hairagasu yai, argan plane hairagasu yai. Si important ni ko. Argan plane define tawba hairani. Argan plane is the plane in which all the complex numbers are located. Now let us consider a complex number z. Habase consider tore ko. Magi real part in x ne, imaginary part in y neba, and this complex number z is represented by this point P whose coordinates are x and y. XY sin represent all ko. Dudi koinas ta kai ani draw a right angle triangle OPM. Draw PM which is perpendicular to x-axis and draw PN which is perpendicular to y-axis. Then this PM represents x and this PN represents y. PN is equal to OM and this PM is equal to kaigamanani NO tani ko. It's the right angle triangle pange. We get a right angle triangle OPM and OP is the hypotenuse. By Pythagoras theorem, this hypotenuse OP represented by R is given by x square plus y square ki square root na pire. Sige se kai represent in the real plane, the distance of the point P whose coordinates are x and y from the origin is denoted by or is given by root over x square plus y square. In the argan plane, this is called the modulus of the complex number z. Modulus have a command defined the way. Modulus of the complex number z is defined as x square plus y square, where x is the real part and y is the imaginary part. So root over x square plus y square represents the modulus of the point P. Modulus of the complex number z niko. Duga nangi complex number z se kanana represent tawgre point P sin. The modulus hai the tariba number se kai tare. Modulus hai tardi the distance of the point P representing the complex number from the origin. Origin dagi nangi complex number ama represent tariba point se kyam la P have the modulus na P rani. Next topic is polar representation of a complex number. Complex number amagi polar representation ko. Let P, X and Y represents a non-zero complex number set X plus IY, and let the length of OP be equal to R and theta be the angle made by this OP with the positive direction of x-axis in anti-clockwise direction. O dagina P bao sa akoina distance se R nen loreba. Dugo OP ga x-axis ka gi make to riba angle se theta lore ko. Theta be the angle made by this line OP with the positive direction of x-axis ore ko. In anti-clockwise direction, then this point P is uniquely determined by the other pair. Karamba other pair na represent tawgre R ga theta ga na represent tawre ko. And these are called the polar coordinates of the point P. X, Y se in terms of R ga theta ga de express tawgrani ba. Adugi representation do na kai kaurakani polar representation kaudani ko. In the figure we see that OP M yes draw M PM which is perpendicular to x-axis. Then we have a right angle triangle OPM right angle at M the right angle tare ko. Do this sigi x theta sigi kai oi. Theta sigi adjacent ko means in a cos theta haiba kanda kai gamana ni cos theta is equal to x by R. Sin theta hai tardi y by R oidoini ko. In the figure, we see that x is equal to r cos theta and y is equal to r sin theta. And therefore, the complex number set x plus iy can be represented as, then replace this x by r cos theta and y by r sin theta. R is common to first term and second term, and we have r cos theta into I sin theta. This representation is called the polar form of the complex number. Complex number dugi polar form kawi ko. Have the xy say in terms of kaide express tarakpa r ga theta ga da. And also r which is given by root over x square plus y square. X is the real part, y is the imaginary part, is called the modulus of z, and this theta. Theta dinga sai kai haigi. Theta is the angle made by the line OP with the positive direction of x-axis in anti-clockwise. Anti-clockwise the low bo oigada banimadi. Clockwise the low yante ko, and is called kai kogre. Argument kore ko is called the argument of z, and it is denoted by ARZ. Argument hai taradi ARZ haina iraktar. Koina polar representation hairani, argument hairani, modulus hairani ko. Next topic. Algorithm for finding the argument of z. Complex number z is equal to x plus iy. Complex number amagi argument puthokpa. Argument means angle niko. Angle made by the line OP. Here point P represents the given complex number. Steps number 1. Find the value of 10 alpha. Nangi hanba step se kaino. Find the value of 10 alpha. 10 alpha is given by modulus of y divided by modulus of x. This modulus y is the imaginary part and x is the real part niko. Lying between 0 to pi by 2. 0 dagina 90 baugi marakta leba koina 10 alpha gi value putuani. Number 2. Determine in which quadrant the point P, x, y belongs. Koina karamba quadrant da yauni has the yam line khangi. Kamaina khangi. First quadrant the all the coordinates are positive. Positive way ko. Second quadrant the x negative, y positive. Third quadrant the x negative, y negative. Fourth quadrant x positive and y negative. Aduna segi sign sing se check tawrakanda point p se first day yaugani, second day yaugani, third day yaugani, fourth day yaugani habasida haiba ngammaneba. Roman number 1, if the point p x comma y belongs to the first quadrant. Sina ihananba first quadrant the layram taragadi, then this argument of z se theta se hoidiniko. Argument of z is equal to alpha. Alpha the modulus of y, the modulus of x in a divide over means alpha is the angle between this OP with x-axis. It may be positive x-axis or positive or negative y-axis. X-axis is positive go oiba negative go oiba oininga side ama go oiba ba. Aduga theta sidi o x tagi haurakpase china anti-clockwise ta lairakpa oigadamne ko. Argument of z se alpha tare ko. Alpha tare karam kanda if the point P belongs to first quadrant. Second case, if the point P belongs to the second quadrant. Sigi point P se here OP represents a given complex number x and y. Then draw PM. PM, which is perpendicular to x-axis. This side represents y, this side represents x, and alpha. Alpha is given by modulus of y divided by modulus of x. See angle se alpha nebako. Theta di o x tagi horaga OP se. Sina theta, sina alpha. Sigi diagram sidagi alpha plus theta ki value se kya tabam to a. Alpha plus theta will be equal to pi tabam to a ko. Straight angle lamane. And so this theta means argument sine ko. Argument of z se. This theta will be equal to pi minus alpha. If the point P belongs to second quadrant, then the argument of z is given by pi minus alpha. Sigi theta lakpay mong se khangani. Consider OX as the initial line and OP have a line am learning ko. Then the distance between the angle made by this OP vector with the positive direction of x-axis and anti-clockwise direction is represented by theta. Number C. If the point P belongs to the third quadrant the layramagadi OX tagi layrakpasina OP da taduin. This angle represents theta and first row PM. This side represents y and this side represents x. Alpha is the layrekwa. Alpha is my informed. Alpha is given by modulus of y divided by modulus of x. Sidagina sibaw se kyano straight angle se. Straight angle am se pi tarekwa. Pi plus alpha is equal to theta lakadab. So argument of z will be equal to pi plus alpha. Sibaw sida pi lere. Sigi matik alpha si hapeva. Pi plus alpha will be equal to argument of z. Number D, if the point P belongs to fourth quadrant. Nangi point P is in a fourth quadrant. The layer magadi point P coordinate is x and y. O x tagi kwena rotate tawa hore duga o p bawla eko. This angle represents theta and this angle represents alpha. One complete revolution is equal to 360 degree in radian, which is equal to 2 pi. 2 pi have a sigma ko. Then 2 pi complete wigadaba alpha se what level. So if p x comma y belongs to the fourth quadrant, then the argument of z will be equal to 2 pi minus alpha or kaigamanarani minus alpha. If the angle is measured in clockwise direction, then its measure will be equal to minus negative sign ama hapkani ba nangi angle sina clockwise direction that measure tawragadi. Tuna nangi argument puthokpase argument puthokpagi rule se steps oina ani lere ko. First find the value of tan alpha, then second the quadrant se first day yagadra, second day yagadra, third day yagadra check tawrani. First day yaragadi argument of z se alpha ni, second day yaragadi pi minus alpha ni, third day yaragadi pi plus alpha, fourth day yaragadi 2 pi minus alpha or minus alpha. Si mong de lai ko. Howse ko na exercise 5.2 yengase ko. Find the modulus and arguments of each of the complex number. Complex number question number 1 to the pirisigi modulus ne argument ne putho. Argument ding sagi theta do idini ko. Exercise 5.2 question number 1. Here the given complex number z is equal to -1 minus I root over 3. Let x plus iy be equal to the given complex number -1 minus I root over 3 siga manahalle ko. Siga manahalle to the x ka y ga gi value iro. X represent a real part. X habasina real part ni, y habasina imaginary part ni. Then value of x is equal to -1 and y is equal to minus root over 3. Modulus. The modulus of complex number z is denoted by this symbol and which is equal to root over x square plus y square tagi ko. X square di -1 whole square plus minus root over 3 whole square. -1 real part square plus imaginary part square equals to -1 whole square is 1 and the -3 square is equal to 3 and root over 4 is equal to +2. Sina nangi modulus lere ko. Then nangna argument hotpagi ahanba step se 10 alpha ne. Find the value of 10 alpha lying between 0 and 90, which is given by modulus of y divided by modulus of x. Modulus of minus root over 3 is root over 3. Modulus of -1 is equal to +1. Root 3 tare ko. 10 alpha na root 3 tava angle puto. Find the angle in which its 10 value is 30. Its 10 value is root over 3. Which implies that this alpha will be equal to 60 degree in radian, which is equal to pi by 3. Pi habase 180 ka manay ko. Aduna dividing both sides by 3. 3 na divide already. This 60 degree will be equal to pi by 3. Pi by 3 ore ko. Hazing nangi alpha se pi by 3 ore then check the point P representing the complex number belongs to which quadrant. Nangi point P complex number represent the point P se karamba quadrant the yauge check tawraseba. Since point P haraga x comma y lakadam ni ko. X की value से क्या आना सीधा here the value of x is equal to -1 and value of y is equal to minus root over 3. Minus का tatari lies in the third quadrant. If all the coordinates are negative, then that point will belong to third quadrant and therefore the argument of z will be equal to, if the point P belongs to the third quadrant, argument of z is pi plus alpha niko. Here value of alpha is equal to pi by 3. LCM is 3 and the 3 plus 1 is equal to 4 pi by 3. 4 pi by 3 is the argument of the complex number z. Complex number z to gi argument laser. Next question. Question number 2. Here z is equal to minus root over 3 plus I. Let x plus iy be equal to the given complex number -3 plus I. Have a siga manahalle. Then x is equal to minus root over 3 and y is equal to 1. X is the real part and y is the imaginary part, and therefore modulus of z is equal to root over x square plus y square, and which is equal to -3 whole square plus 1 square. 3 plus 1 4 dum 2 dareko. Now find 10 alpha. 10 alpha is given by modulus of y divided by modulus of x. Here value of y is 1 and the value of x is equal to minus root over 3 and modulus is root 3. 10 alpha 1 by root 3. 10 alpha 1 by root 3, which implies that alpha is equal to 10 alpha sina 1 by root 3 taba. Alpha gi angle se kaida tai haitaradi 30 the darega 30 degree in radian, which is equal to pi by 6. Then check the point P representing the complex number belongs to which quadrant. Point P x comma y. Here x is equal to minus root over 3 and y is equal to 1 lies in second quadrant. Second quadrant the layer is a x in a negative ne y na positive tareko adudi mase second quadrant the layer. If the point P belongs to the second quadrant, then the argument of the z will be equal to pi minus alpha. Pi value of alpha is equal to pi by 6 and their LCM is 6. 6 pi minus pi is equal to 5 pi by 6. Next question is convert each of the complex number in polar form. Polar form that see the period complex number ma'am say polar form the igedabako. Polar form hai tardi r into cos theta plus I sin theta gi form se polar form ni r haibasina kaina pire modulus of the complex number na pire aduga theta aduna kaino theta sina argument ni ko theta is the argument of the complex number z. So for question number 3, let z represent the complex number 1 minus I be equal to x plus iy. Then write the values of x and y. X is the real part, y, and y is the imaginary part, which is equal to minus 1. X in a 1 tare, y in a minus 1 tare ko. Then find the value of r. This value of r is given by the modulus of z, which is equal to root over x squared plus y squared. 1 plus 1 is root over 2. Here we have the value of r. Then find tan alpha. Tan alpha puthoisi kaigino haradi koina argument puthokpai ko. Tan alpha is equal to modulus of y divided by modulus of x, which is equal to 1 divided by 1 is equal to 1. And so this alpha is equal to pi by 4. Habadi tan alpha na 1 taba angle se 45 neba in radian, which is equal to pi by 4. Nangi point P se karamba quadrant the yauge have a check tawasiko. Since the point P representing the complex number x comma y, here x is equal to 1, y is equal to minus 1. Since point P, x is 1 sina plus ni, sina plus ni, sina negative ni, fourth quadrant the then theta will be equal to 2 pi minus alpha. Then replace this alpha by pi by 4. LCM is 4 and 4 into 2, 8. 8 minus 1 is equal to 7. Then pay fangyo r की value से फंगे, theta की value से फंगे को. Now write the polar form of the complex number z. The polar form of the complex number z is given by r cos theta plus I sin theta, which is equal to root over 2 cos 7 pi by 4 plus I sin 7 pi by 4. See mong de le ko. Next question, question number 6. Here z is equal to minus 3. Z से minus 3 ने minus 3 से purely real number or imaginary part yaudre ko. Then this minus 3 can be expressed as minus 3 plus I into 0 is equal to x plus iy. Then write the value of x and y. X is equal to minus 3 and y is equal to 0. Yauramdaba saruk se koina multiple of I into 0 and thamme ko. Then r puthose. R is given by the modulus of z, which is given by root over x squared plus y squared. 3 squared 9 plus 0 is 3. Then find tan alpha. Tan alpha is given by modulus of y divided by modulus of x. 0 by 3 is equal to 0, which implies that value of alpha is equal to 0. Sinang tan alpha ki value hole alpha putok pangamme ko. Then point P se first quadrant the yaubra, second the yaubra check tawasiko. Since the point P representing the given complex number whose coordinates are x comma y. X means real part minus 3. Y means imaginary part lies in. Here coordinate of x is negative sign, coordinates of y is positive sign, so it must belong to second quadrant, and therefore theta will be equal to pi minus alpha. Pi minus 0, pi tareko. The polar representation of the complex number z is given by r cos theta plus I sin theta. Then replace this r and the theta by replace the rani 3 and pi respectively. Replace r by 3 and this theta by pi. This is the polar representation of the complex number z is equal to minus 3. I have a complex number segi polar representation. For today, let's end here.